So what I will do, if it's okay with you, Aaron, is hand over to you to...
Sure. Let's...
Sure. That was a short warning, wasn't it? Throwing you in the deep end.
There we go. I'm going to assume I can't actually see anything
You're
other
good.
than because I'm just presenting full screen, so I can't see anything else. So let's get started. Sorry, I've been watching llamas, not the other talks. My apologies to the other speakers. Let's put the llamas to the side. So welcome to the last talk of the evening. My name is Aaron Powell. I am a cloud developer advocate at Microsoft, and I've been doing web development for longer than I care to admit. I remember browsers that no longer exist and all sorts of stuff like that. So I've been doing this kind of stuff for a while. And something that I have recently been playing around with is GraphQL. Now, anyone who does follow me on Twitter, and social media stuff is across the bottom there, will know that I've been very much a skeptic of GraphQL over the years. I have more than once called it just a fancy version of OData. But what I've realized is that there is actually a valid reason that people are looking at it, and I wanted to play around with it and see what that was. And what I've realized is that we're building a strongly typed schema that represents the way that we're dealing with our data model, but that schema doesn't then get translated into code. So I wanted to have a workout of a way that you could do that so that you would actually have the code that you're working with validated against the schema that you've built. So let's have a look at how we can do that. And I have written 0 slides for this, so we're just going to do everything in code. So I'm going to start off by creating a GraphQL schema. So this is going to be a GraphQL application that will be backed by a TypeScript. Well, it's a TypeScript code base, but GraphQL. So we're going to start by creating some types. Okay, so it's a quiz application. So we've got questions. It's a type. It's got some fields on it. The fields have data types against them, strings or arrays, and the exclamation points indicate whether or not they're allowed to have nulls in them. And then we can create a schema, and that schema is the thing that you're going to interact with as a consumer of GraphQL. So it's got a query that's got a couple of functions that you can execute. Question, which you provide it with a ID, or just get a random question, and that's then exposed out. So this is the sort of thing that you're consuming. If we jump over to the index, so this is the application actually as its entry point. It's running the Apollo GraphQL server, and this is done in an Azure function. So it's serverless GraphQL running a server, and then it's talking to Cosmos DB behind the scenes, which is a serverless database running serverless to run servers, because we are actually servers all the way down. I'm going to pop the schema over to the side so that we can keep that as a reference point. And another thing that I've also done is I've already gone ahead and written the data model that is actually stored in our database. So we've got a question model. So this is the thing that's in our database. And we'll see that it's kind of similar to the data structure that we're actually getting back from GraphQL. It's got IDs, it's got question, but it doesn't have all of the same properties. There's a correct answer is actually cased separately or differently to the way that our data model is. And we don't have an incorrect answers array. We have just an array of answers. Because you don't want to, as a consumer, just have to always build up the full answer set. You should just be able to get the answers regardless of whether they're correct or incorrect, and then have another way to do that validation. And some other fields that I've just decided that are useful in my database, but not for my GraphQL schema to expose. Now we need to go and implement this somewhere. So to do that, we're going to create a file called resolvers.ts, which I have already created for us. If I scroll up, you'll actually see the code. And inside of the resolvers, we have a thing that it's kind of matching what our query syntax looks like. We've got a couple of functions, one called question, one called get random question, and those are going to allow us to get data out. But now it's starting to feel a little bit, well, we're losing the value of a type system, right? Like, I'm in TypeScript, so I should have a type system, but I don't know what this is. It's currently a void because that's what it's detected it as. So I know that there's a first argument that's provided, which is the parent of this particular object in the resolver graph, but that parent is going to be null in this case because this is the root of the resolver graph. I know the second argument is going to be the parameters that were passed in, if there were any. So I know that's going to be ID. And then thirdly, we have context, which is kind of like a way that you can pass in things that the server always has access to. So that would be where you have your data connection. So data store, which I've already set up. now, because I've written this code base, I know that I can do return data store dot get question by ID, and I can provide it with the ID. Now, I know that that works because I've written all of this code, but this is TypeScript, and like I should be getting some some validation of that. It's not an any; it should be a string. The data store should be a type of my data store. Like this should be a known method and that sort of stuff. But I've defined that these have got expectations on what the return values are, but I don't have any of that stitching together, which you really want. So that's where I decided that I wanted to try and figure out how we could do this better. I came across a tool called GraphQL CodeGen. And for that, I'm going to open up a YAML file and I'm going to insert some stuff. And this is the schema for the CodeGen file. I provide it where my GraphQL schema lives on disk. So that's to the .graphql file. I could also point this to like a HTTP endpoint. So if I was just using someone else's GraphQL schema and I was like, that was my starting point, I can point to that. But it's got to be a GraphQL schema in some regards. I'll skip over documents. We'll come to that at the end. The really important thing is this generates node. Inside of generates, I define files that I want to generate. So first off, I've decided that I'm going to have a TypeScript file, which will contain my TypeScript definitions that you're going to generate from my schema. Because I've already defined some of these types themselves, so if we have a look back at our data, I have question model. Now, I want when you find a question type in my GraphQL schema, this is the underlying type in TypeScript that I want you to represent it as. This is what my data model is. Similarly, I have context defined down the bottom, and that's a type that I want available. So when you are generating with the context for my GraphQL application, there's a type in TypeScript that I've already defined and I want to make available because it relates to the thing that I'm generating here. The plugins that this is using for TypeScript and TypeScript resolvers, just so it can generate the appropriate code. This tool can actually be used to generate C# code and Java code and a couple of other languages I can't remember off the top of my head. Finally, I'm generating a schema JSON file, which is just going to give a consumer of the schema some like IntelliSense and schema definition and stuff like that. That's what the introspection plugin does. So let's kick this off. So we're going to start a new terminal, and then I'll come into the API folder and npm run gen watch. So this is going to just start up the code generator, and we'll see. There we go. It's running the watch. And now we have a file called generated.ts. If we have a look at this, it's got a whole bunch of stuff. Have our schema over the side. And actually, it's looking pretty much the same, isn't it? We have an ID. It's a scalar type, which is the way it's representing ID and string and bool. So these GraphQL built-in primitives, they're all available there. Excellent. If I scroll right down to the very end, we see we have resolvers. Oh, that looks interesting. So now if I come back to my resolver, like I want to be able to type this and use that new information. So if I import, wrong brackets, resolvers from generated, and then I type this object to that type definition, we've got our first red squiggle of the night. We'll come back to what that red squiggle is, but if I hover over, say, the ID, ta-da, now we've got some type safety because it knows that the question, based off our GraphQL schema, is going to have an ID property, which is a GraphQL ID scalar type, which is translated to a JavaScript string. That's the representation in JavaScript that we've got. Similarly with data store, because we typed our context through the config, it knows what it is. And I know that get question by ID exists. It returns a promise of question model. Fantastic. Let's go ahead and implement the other function that we have here. And that will be another little bit of shorthand that I've done, code that I've written beforehand. Excellent. So now my server is up and running. We pop open a browser and we'll go to where I have my server running, localhost 7071 GraphQL. So this is the graphical playground. So this is just a tool for inspecting and playing around with GraphQL endpoints that I have running with inside of my application. I can pop the schema over there, which will give me information about the schema that I've got. But I want to write a query. We're going to do a question, and we're going to grab the ID. Actually, no, we'll go get random question. We'll grab an ID, we'll grab the question, and we'll grab the answers. And then we'll hit execute. And we get an error. Yay for live demos. It's all good. I actually know why we got this error. And if we have a read of it, it says it cannot return null from a non-nullable field, question.answers. We pop back here, makes sense. Answers is defined as a non-nullable array of non-nullable strings. But if we have a look at our data model, back up here, we don't have answers as a field. We only have incorrect answers and correct answer. So what we need to do is we need to then expand on the resolvers that we've got to be able to map that model to the actual resolvable type. So I'm going to inject some more code that I've written earlier. And now I have questions, which is a property of my resolvers. It's how you resolve a particular data model. It has answers, which is a thing I need to resolve from that model. It gets a root object, which is the questions model. And then it needs to return, if we just hover over that, it needs to return a string array, which I can then do by unpacking my data model. And I'm just doing a very simple thing where we'll just concat them together and then sort them. Similarly with correct answer, well, I need to rename that from correct underscore answer to correct answer with the capital A. ID and question, I don't need to put in there, but I just wanted to illustrate that you can do it for fields that already exist, but you could remove them and it would just work fine. Back to our browser, hit execute, and fingers crossed, we now get a random question and we can work out which is the correct answer for that question that we have there. Awesome. Now we could do a similar thing if we say wanted to do a mutation, which is how we update data. So I'm just going to inject the full completed schema. I've now added a new type called answer. I've added a mutation operation, answer question, which takes a couple of arguments, and then a schema, which now is updated to have our mutation. I could come in and then implement, add the mutation handler. Oops, not that one. Implement, no, create mutation. There we go. Look at my snippets. And here we go. Answer question maps to our schema. ID is a string. Answer is a string. We get our data store and we have to then return our answer model. Now, answer doesn't actually exist in our data structures in our database. So I'm just dynamically creating that. So I don't need a custom resolver to deal with all the properties in that. So now if I go into GraphQL, I could then answer a question and then see whether I got things right or wrong. But instead, I wanted to look at the final thing of how do we combine this into our UI? I'm building a React application for this, and I know that there's going to be a couple of operations that you need to do. One of them is going to be get random question. So I've defined in GraphQL, this is an operation that you might want to do. Get random question, it's going to give you the ID, the question, and the answers. So just what we were doing in GraphQL anyway. But I want to make that easy to use with inside of React. To do that, I could generate some more code. So I'm going to inject some more stuff into our config, which is going to generate me a new file, which is a TSX or a TypeScript React file. It's going to generate with hooks, without higher order components or normal components, using the TypeScript, React, Polo, and operations plugins. This is where it's looking at that documents node at the top. So reading all those files in there, and then it's going to generate me some higher order components or standard components or React hooks, which is what I've enabled in this case, that I can then use inside of app.tsx. So here I have imported from my generated file, use answer question mutation, and use random question lazy query. Now, if you're familiar with React and React hooks, this is the pattern that we use for a React hook. If you're not familiar with React hooks, that's okay. Hopefully it's making a bit of sense of what the intent is from those names. So we're using something that's going to perform that get random question function. If I just scroll down a little bit, actually, I'm just going to close off so we have some more screen real estate into our app. We see that I can say get random question using the lazy. So the lazy just means that it's only going to return when I explicitly request it, not immediately return the result of hitting the endpoint. It's going to get the random question, and then we're going to get some other things like some loading or data if I hover over that, and we can see again, it's more strongly typed information. It's the random question query, which if I come back into my operation that I defined, only has those 3 fields. So it's then generated a new type that represents all of that. It's then just working with React hooks the same way as we'd work with React hooks in any other application. I can use them with effects. I can combine multiple hooks together. I can have multiple non-GraphQL based hooks that I'm using, as we can see throughout this application. Now, that's all I was planning on covering tonight. It's a really quick look at how we can get started by using TypeScript, GraphQL, and the GraphQL code generator to add some type safety into a GraphQL-centered application. I'll share the Git repo for this application that I built into the chat on Zoom. I'm like, what platform are we running? It's Zoom. Tonight it's Zoom. I'll also tweet it out on Twitter for anyone that wants to grab it off there instead. But I hope that was interesting. I hope that gave you a taster of what you can do with GraphQL and TypeScript. And I will stick around for any questions that people have.
That's great. Thank you so much, Aaron, and thanks for staying late with us since we're all over the show. You got kind of punchlined along the way. People solved your problem before you solved it.
I didn't doubt that they would solve that. Oh, wait, where's the stop share button? There's the stop share button.
But there was a question from Alexi around how heavily is GraphQL used inside Microsoft at the moment? Is it supported with .NET Core? Can everyone go there?
Yes. So, like, there's so many teams that it's hard to give you any kind of accurate answer on who's using it and what are they using it for. I'm actually partway through writing a blog series around how you can deploy GraphQL servers onto Azure. I'll pop the link to that series in chat as well. I actually just did a post on doing a .NET-based GraphQL server running in Azure Functions, talking to Cosmos DB. So that kind of end-to-end of a server endpoint to data model to storage. In terms of like, do we have a .NET GraphQL package? No. There's some fantastic open source GraphQL packages out there. There's Hot Chocolate, there's GraphQL.net, to name a few. Use those. Don't wait for Microsoft to produce one. Similarly, if you're looking for one that's written in JavaScript or for JavaScript or TypeScript applications, use something like Apollo. It's there, it works. Like I actually don't think that there's a need for Microsoft to go out and create their own. I think there's value in maybe like if we've got things that expose as REST endpoints, maybe they're useful to also have GraphQL. But in terms of actually shipping GraphQL as a .NET library or GraphQL as a Node package or as a Python package, Microsoft can't bring anything that the community is not already attempting to solve. So I can see in the chat, there's a kind of a follow-on question to that of, does GraphQL, does Azure have something similar to like Amplify from AWS or AppSync from AWS? Short answer is no. And that's part of why I started writing a blog series on how do you deploy GraphQL on Azure, because we don't have like a click button deploy GraphQL server. And there's pros and cons to just having like GraphQL as a service for a generic data model. But we just aren't in the space to have that at the moment. And I'm going to ignore Ben, who likes beer, just because that's a complete troll question. And he obviously has not had enough beer to drink.
Oh, I love that. You just made my life so easy. And yes, Ben, who likes beer. I like that. Thanks again, Aaron. That was fabulous.